In this video, I want to show you how you can create a digital twin robot in Unity. So the concept is that I have two robots, one with ROS 2 and another mimicking its movements in Unity. The one running ROS could be a real robot if you have it available, but in this video it's going to be fully digital. So I chose the Franka FR3 because it has all the necessary resources freely available. But bear in mind that it's a work in progress, so you should be prepared to meet some bugs. To get started, I would just follow the Franka Robotics GitHub README, which I'm showing here. It has two main branches. It has the Humble and the Jazzy, depending on which version of ROS 2 that you're using. So there are multiple ways to get started on this. You can do it locally or with Docker or with workspaces, depending on what you want. This will provide everything you need for the ROS version of the robot. The next step is to create the URDF file, which you can find in the Franka description on their GitHub page. This requires Docker. But before that, right now I'm creating a shared folder. This will allow me to create the URDF file in my virtual machine and then share it back to my Windows machine. We also need a shared folder later for some ROS messages. So I'll just get started with that. Now I'm showing different ways to mount the shared folder. The first one didn't work for me, it might work for you. The second one did, and now I'm just automatically mounting it to whenever I boot this virtual machine, so I don't have to think about it anymore. Alright, so let's check if it's mounted. Yeah, there you go. Okay, so now let's get started on the URDF file creation. You just clone the repo. And then make sure you have Docker engine, or else this won't work. Yeah, and there was an error. Something with a user. Other people has commented on this, so I found a quick fix. You remove all the user arguments. and I forgot to change the owner to 1001, which in the Docker files it explains that it should be 1001. And yeah, then it just built normally. So now I'm opening the shared folder I just created, and I'm going to drop the URDF file. So alongside with this URDF file, we also need the meshes of the robot. And take note that the path is important, so you should keep the same names and the subfolders. I actually forgot one, which will cause a problem later, and when we get to it, I'll show you. Alright, let's check if it's there. And yeah, it all looks good. So let's try to import this into Unity. Let's create a new project. Use the latest version that I have. Yeah, so we now need two packages, the URDF importer and the ROS TCP connector, both by Unity Technologies. Those can be imported with the Git URL, so if you find their respective repositories, yeah, you can find the link there. So the ROS TCP connector is for Unity, and the ROS TCP endpoint is for Ubuntu. Or wherever you're launching the ROS robot from. So now we have those two. We can try to import the robot. So I'll just create a folder, name it FR3, and then grab the meshes from the shared folder and the URD file. And now here comes the problem that I stated earlier. Yeah, as you can see, I forgot the Franka description folder. So let's add that, and then it should be correct. And it doesn't have any materials, but there it is. So let's just create some materials. You can just get rid of that one. Yeah, that's fine. The Franka robot is white and black, and yeah. So let's just speed through this. Now this is about what it looks like. Yeah. Alright, so now that we have that, there are some things we need to do. We need to remove the standard controller. This will just mess it up. Yeah, we need to set this with immovable and to use gravity and to set 0 as the base link. And then the drive type of link 1, 2, 3, 4, 5, 6, and 7 should be to target, not force. And after that's done, the base is set up. So let's move on to the TCP endpoint. Let's start by cloning the repository. Also by Unity Technologies. And it's important to get the right branch after you've cloned it. And since you need to build it, you need to create a source file where you can place this repository. So let's change the branch to main ROS2. And now you can build it, and then you can source it afterwards. Okay, now let's try with a default server. Yeah, that works. And now back to this. So the one running in ROS continuously sends joint state messages with the joints and their position. So let's try to take a closer look at what the joint state message is, so that we can have the Unity subscribe to it accurately. Right, so right now I'm in Unity. In order to subscribe to a message, you need to have that message available. So I'm just getting all of them in case I want to work with other projects or other messages later on. You could also just get the specific one that you're after. Yeah, so there are all the available messages that you can build. We're looking for sensor messages and then joint state. Yeah, and then you can hit build. So let's look at what's actually inside the joint state. Yeah, so you have a list of names, position, velocity, and effort. What's important to us in this stage is the name and the position. The position, which is declared in radians and not angles, so we'll need to convert those. And there is a mismatch between the names in Unity and the ones given from the real robot, so we also need to handle that. So right now I'm creating a ROS connection. Yeah, using the IP from the virtual machine. This will allow us to connect with a specific connection. So now it's time to create a script. Okay, Just gotta install some stuff, apparently. Let's start off by having the ROS connection. And then I want to create a dictionary where I can have the joint names given in the ROS message. And then look up on the actual joint based on that. Yeah, I need to turn off the Copilot suggestions. It's just getting in the way. So let's subscribe to the message that we want, which is the joint state message that we just imported. So whenever it receives on that topic, it should do this function. Which is about 1,000 times a second. 1,000 hertz. Yeah, whenever you're importing, you might get an error stating that there's two imported with the same name, but yeah, you shouldn't worry about that. So that's the way the FR3 underscore joint one, that's how they're named in ROS. And then FR3 underscore link one is how they're named in Unity. And what we're after is the articulation body. this is where we can set the target position. So that's what we want. Not the entire component, but just that part of it. Yeah, so let's do the same for all the other joints. Yeah, so let's loop through all the messages that we get, all the names in the messages that we get, which last I checked was 9, because there are also some finger joints which we need to exclude because we don't need their position for this example. So now we're just getting the articulation body that we want, so that we can set the position. So let's see, yeah, so inside the X drive you have the lower and upper angles, and then the target. So we need to convert from radians into angles. And you do that by multiplying by 180 and divided by pi, and then cast it to float. And that's how you update the X-drive. And don't forget to actually add the script. You can just drop the ROS connection now. Alright, so let's try to start up a server and launch a Franka gazebo bring up example. So there's an example. And then you also need to change it to ROS 2. I forgot that in the ROS settings. And now it would work. However, the joints would be a bit sticky because of the predefined acceleration. So just remove those. And then it springs into place. And yeah, now it's following its movements. However, that one's not moving, so let's try another example where I've now loaded a controller which will move it back and forth, and as you can see, the Unity follows its positions